Hi, everyone. This is my first ever broadcast, so do go easy on me. For those who are watching, this is a broadcast being streamed on YouTube Live. We were also supposed to do it on LinkedIn, but for some reason, there's some issue with LinkedIn. Nevertheless, we're going to be distributing this after the broadcast as well. So, just quick introductions. My name is Abhay. For those of you who don't know, my name is Abhay. I run a company called V45. I do a lot of, I started off as a pen tester, but I do a lot of automation and building work today. So, I do a lot of development. I'm one of the authors of our tool, vulnerability management tool, which is Orchestrate. We have a lot of open source projects that you should check out: Orchestrate, Threat Playbook, which is a threat modeling project, and a serverless security project as well. Aside from that, I do a lot of training and speaking at major events like DEF CON, Black Hat, and so on. I do a lot of training, and whatever I research, I also put into my training, so that kind of becomes like a cycle of sorts. In fact, the stuff I'm going to talk to you today about is also kind of going into some of our training programs as well. If you want to follow us, this is our social information. Twitter, we are on at V45. I am at Abhay Bhargav. Of course, you can follow us on LinkedIn on either my profile or V45s or both. One of the things that we're doing for April, May, and June, and I hope all of you are staying safe, is that we are running a lot of remote or live online trainings. So today's topic is going to be DevSecOps. So we have a bunch of DevSecOps classes that we're running. Aside from that, so you can look at the dates, and I'm also going to be sharing a URL for our DevSecOps classes right here. You can look at our list of remote trainings. We offer everything from Kubernetes to DevSecOps to application security, and you should be able to sign up for one of these classes and get the best of what we have to offer in terms of labs and so on and so forth. So that's what we have from a DevSecOps perspective. These are some of the dates we're running our DevSecOps classes. Also, what we offer as part of our training, you have the training itself, which we are really good at. The cloud labs and cyber ranges are something that's quite amazing. We also have certification and post-training access to labs and videos. So with that out of the way, I'm going to get started with our core subject today, which is going to be integrating ZAP with GitHub Actions. Right now, if you are interested in communicating with me, please send me messages on our YouTube stream, and I'll try and answer them as we go along, and I'll try and put up some of the messages that I believe will help the audience also make add some more value to the audience as well. So please respond on our YouTube channel, and please subscribe to our YouTube channel because we keep putting out a lot of awesome content, which is completely free for you to use. So let's get started with our topic for today, which is ZAP with GitHub Actions. So basically, I don't know how many of you have tried to automate DAST. So I'm sure some of you are watching this video are already doing some kind of automation or are trying to do automation, or maybe in the beginning stages of your automation journey. So when it comes to automation, you might be automating some tools like static analysis. You might be automating dynamic source composition analysis, and so on and so forth. You might be using different tools to do this. Some of you may be using open source tools. Some of you may be using more commercial, or your organizations may require you to use these commercial tools. So you have all of these options that you're using. But one of the common problems that I've always seen going into any kind of DevSecOps project is automating DAST, right? Now, when I say DAST, I'm talking about dynamic application security testing and vulnerability scanning, right? So you're typically talking about tools like Burp Suite, ZAP, W3AF, other commercial ones like AppSpider, AppScan, what have you. You have several tools out there. So the one of the challenges that I have faced typically with such projects is automating DAST, because DAST runs for a very long time, and you also don't really have a lot of challenges with DAST because APIs don't work. You're not able to get the authentication working, especially with single page apps and REST API and so on and so forth. You're not able to get the authentication working very well. So it becomes a big challenge with DAST, right? So today I want to talk about a little bit about automation itself, and we have a bunch of automation projects that you should check out. In fact, one of the projects that I'm that has been a major cornerstone for V45 is the free ZAP mini workshop. You can actually check this out on our GitHub link. I'm going to post the links out here. You can check this out. This teaches you a little bit about ZAP's API and so on, but of course, we cover this in much more detail in our classes and so on. So this is a free resource that you can check out. It's out there. A lot of folks have used this and found this extremely useful as well. So coming back to our original point, which is essentially automating DAST is a little hard, especially because APIs don't work and so on. So today what I'm going to do is I'm going to do a coding session where we're going to look at an example. I have an API. That API has been built is an automation framework that has been built by GitHub itself. This is supposed to be a substitute for traditional CI services. So if you used Jenkins or Bamboo or Argo CD or what have you, or several other tools, there are thousands of tools that do CI/CD. There's a good chance that you know what CI/CD is. If you've used any of these tools, you've probably dealt with CI/CD. You've probably looked at a bunch of CI/CD use cases. So GitHub Actions is a framework that helps you run CI/CD use cases or CI/CD jobs on GitHub itself. So GitHub provides its infrastructure, like its servers, its orchestration system, to run your jobs as soon as check-ins and so on, and all of that stuff happens. So the first thing I'm going to do is look at what I want to happen on my desktop, and then I'm going to show you the GitHub Actions example as well. So the first thing I want to do is I have my app, which is a REST API. This is an intentionally vulnerable REST API. It has a bunch of security flaws. So the idea here is I want to automate and find security flaws with ZAP. So I want to use ZAP to be able to find these security flaws and then obviously report on these security flaws. So what I'm going to do is, and the thing is, this is a REST API, right? So I don't really have, I can't really scan without authenticating. So if I try and use ZAP Spider, it's really pointless because a ZAP Spider does not really is not able to find these other URLs, and it's not going to be able to make those requests. So one of the things you must know, especially with DevSecOps and a lot of DevSecOps use cases, is that when you have DevSecOps, when you want to automate some of these tools, one of the challenges you're going to run into is if you don't run them with some kind of authentication, you're going to see that a lot of these tools just don't find anything, right? Because they're built to spider, and that's how they used to find stuff. But without the spidering, today you will see that pretty much nothing works, especially with single page apps or when you're talking about REST API, there's no real concept of a spider. So what you have to do is use some kind of test automation to proxy all that traffic through the DAST tool and be able to scan after that. So I've written a small end-to-end test here, and I'm also going to be sharing the code with you. Actually, I can share that repo right now. I'm just going to be pasting it here. So this is the repo that I'm going to be using for running this example. This is an intentionally vulnerable app that I use for a lot of my demos. So here what we're going to do is I'm going to run this. So what's happening here is I'm going to log into the application, to the REST API. And once I log in, I get JWT or an auth token, right? Now, those of you might be familiar with JWTs. It's essentially once the user logs in, there is a stateless token that is issued to that particular user. The user can use that token to access the application up to the time the token is valid. So here, I try and log in. Once I log in, I get an auth token. Once I get the auth token, I perform all my subsequent requests with that auth token, right? Keep in mind, I perform all my subsequent requests with that auth token. And so I'm running, all of this is going through as an authenticated, authorized user of that system, right? All the while when I'm doing this, I'm proxying all of that traffic through OWASP ZAP. So I have OWASP ZAP open here in GUI. Of course, you'll see that in GitHub Actions, you don't have the GUI. You're going to run it as a daemon. So you'll see that all of this is running as, you'll see that OWASP ZAP is populated once I run this particular test, right? So I'm going to just open up my terminal and go into tests, and I'm going to run my end-to-end test. And you'll see that the first thing this is going to do is it's going to walk the entire application in an authenticated state. And then it is going to use ZAP's API. So ZAP has, so one of the things you should know about ZAP is that ZAP is probably the best tool to automate from an API perspective. It has a really powerful, really strong, really solid API. Whatever you can do with the ZAP GUI, you can do with the ZAP API as well. So yeah, so I'm using ZAP's Python API. ZAP has JavaScript API. It also, I think, has a Golang API as well. And of course, I think it has a Java API. But even if you don't have these native language SDKs, you can use ZAP with its REST API. So I'm using ZAP's REST API, and I'm going to start a scan. Now, remember, I'm not spidering the application. I'm not at all spidering the application. I am just starting a scan because all of the stuff that a spider should have done is being done by my test automation script. So it's essentially like a user walking through the application and then running, then starting a scan. So it's almost mimics a manual vulnerability assessment engineer or a pen tester running this stuff, right? So we are starting a ZAP active scan. And once we're done with the active scan, we're going to throw out a report, which is a JSON report in the same path. So that's what's going to happen. I'm going to first demo this on my desktop, and then we'll see if the same thing works with GitHub Actions. So the first thing I'm going to do is run my end-to-end test. So I run it, and you'll see that ZAP has now started actually scanning. And you see that since we're not spidering anything, ZAP is not trying to find all these URLs. ZAP is actually done. And you'll see the scan actually took very little time. It's actually done. The scan is completely done. It's produced a report, right? So this is pretty awesome. So within a matter of a few seconds, we've had a complete scan done against those 4 URLs. Whatever operations I've been trying to do, you can see that get customer ID by response, fetch customer post response, search customer post. All of these are authenticated, authorized operations I've tried to do as a user. So you'll see that it's found a cross-site scripting bug, it's found a bunch of medium and low severity flaws. But nevertheless, you've seen that it's been able to run a completely authenticated, authorized scan against our application, which is what we want. So now imagine that I'm an engineering team, and I want to do this every single time developers check in code into my repository, right? So let's say I have maintained test automation flow like this, like the one I've written. I've written a very basic test automation script, but over time you'll see that this test automation script. Let's say I add another API endpoint, I can add another function for the test automation script, and it would crawl that. So every single time developer checks in code, let's say I want to scan. Let's say I want to run a ZAP scan. So I'm going to do that with GitHub Actions. Okay. So GitHub Actions, like I said before, is a framework that's been provided by GitHub to allow you to run these kind of CI/CD jobs, right? And this is really powerful stuff. One of the cool things, and I want to talk a little bit about GitHub Actions. Before that, I'm just going to paste a few links, which may be interesting to you to understand how GitHub Actions work. So I'm going to just paste the doc link for GitHub Actions pretty soon. Just give me a sec. Yeah, so this is the doc link for GitHub Actions. You have the complete documentation for GitHub Actions in that particular link, which is quite interesting to read. And you'll get a lot of options. It's very powerful CI/CD tooling. You can simulate tests on different operating systems. You can simulate them with different jobs. You can do parallelized jobs. You can do a lot of interesting things with GitHub Actions. Initially, I was not a fan of GitHub Actions, but then when I actually started delving into it, I found that GitHub Actions was really, really powerful stuff. And I'll explain why it is that powerful and why I really started to grow. It started to grow on me as a framework itself. So let's look at our test, right? So in GitHub Actions, essentially, it's a sequential set of tests that we want to run. So the first thing we have to declare is when we want to run this. So in this case, we're running it. And remember, GitHub Actions can be defined by a YAML. So all you have to do in your repository is open up a .github directory, open up a workflows directory in that .github, and then have whatever YAML, whatever jobs or whatever tasks that you want to run, you can trigger from that particular location. So I have only one job here, which is called zap_test.yml or YAML. Those of you who are not familiar with YAML, it would be good to gain some familiarity with it, simply because YAML is the de facto language of choice when you are writing configuration scripts for Kubernetes, or even for CI/CD, or for a lot of things today in modern DevOps, right? So definitely look at learning a little bit of YAML. So what I'm going to do is just walk through the script a little bit. So you see that whenever anyone pushes some code on the master branch, this is the GitHub master branch, what happens is this job gets triggered. Now this job essentially runs on an Ubuntu 18.04 server. Well, now this is pretty cool because you can actually parallelize the job and run it on different operating systems. So let's say you're trying to test a desktop app. So let's say you're trying to do a functional test of a desktop app. You can run it on multiple operating systems like a Mac or Windows, Ubuntu, and so on. So it's pretty interesting stuff. The other thing we're doing, one of the things with GitHub Actions that I found really powerful is the marketplace, right? Now, the GitHub Actions essentially has a marketplace, which looks like this. So I'm going to just go over to the marketplace and show you what that is. So a lot of other folks like you and me have contributed jobs or different types of tasks to GitHub. And you can find all of this in the Actions marketplace. So let us say you don't want to sit and write your own definition, your own GitHub Actions definition. All you have to do is just use a job from a marketplace. So in this case, what I have done is I have used one job from the marketplace, which is called checkout. So if I look for checkout in the marketplace, you'll find that it is a pretty, so you see that there is a checkout action, and I'm using this particular action. So it's kind of like a plugin of sorts. So if you're familiar with Jenkins, you might be familiar with plugins. I find this to be much more easy to use because it's pretty standardized. The way you use it is also pretty standardized. It usually has some detail about how to use it and what kind of variables it needs when you're using it. So in this case, what I am doing is using a checkout, which is essentially getting the Git checkout on that particular machine. So checking out that entire Git repo on the test machine, which is an Ubuntu 18.04. And then I'm going to install Python, which is also a action that I've used from the marketplace. So I've decided to set up a Python instance on Ubuntu 18.04 with Python version 3.7.6. You can actually even parallelize this. You can even say, hey, test it on Python 2.7, test it on Python 2. Maybe 3.5, 3.4, different versions of Python. So you actually have all of those things you can specify here as part of this particular action. Now, these actions from line number 16 through 19 is essentially what I've written, right? So the first action I've said is install all the dependencies that I want. So these are the dependencies that I need to install for my test to run, right? So I need a library called request that's going to make HTTP request to my REST API. And I also need the Python OWASP ZAP API, which is the officially maintained OWASP ZAP API when I want to run this, right? So that's what I want. The next thing I want to do is I'm going to build the application into a Docker container. So you can see that I'm actually running it as a full CI task. So all the source code of the application is being built into a Docker container with this Docker file. So I have this Docker file here. It is going to build all of my application and its dependencies into a Docker container on that test machine. So remember, we have an Ubuntu 18.04, and we're building a Docker container on that application, on that test machine. The next thing I'm going to do is install ZAP, right? Now, installing ZAP, you can do it multiple ways. I have decided to install ZAP. Let me just shut this down. Yeah. So I've decided to install ZAP as a service on the operating system itself. You can use the Docker container that ZAP provides, but the networking, I realized it's a little bit of a problem, especially since I want to proxy traffic through ZAP. I decided not to use ZAP, the Docker image. I decided to use ZAP as a service. So I install ZAP. Now remember, whenever you're installing anything on the OS in GitHub Actions, you can't install it in root. You can't use the /user path and all of that stuff. You have to make sure that you have to install it in the current temp directory that it gives you. So everything runs within a temp directory, and you have to install all of the dependencies you need, all of the stuff you need within that temp directory. So it's not possible outside. So what I'm doing first is I'm downloading ZAP and installing, and I'm downloading ZAP, the Linux version of ZAP, and I am unpacking that. And then I'm also downloading a plugin for Zap called the Export Report. Now, this plugin is a useful plugin that helps me generate standardized report. Now, the Zap original reporting framework is a little painful to work with, so I decided to use this add-on. And then I am setting a few environment variables and then installing Zap. So this essentially installs Zap, right? That does nothing else. The next job I have is essentially going to run my application. Now, one of the cool things about the GitHub Actions definition is essentially that you need only very few options. You either use a uses option where you're using somebody else's GitHub action, or if you're writing your own, you need to use a run action, right? So essentially, since I'm defining most of the stuff myself, I'm using run. So this is just going to run the command docker run -d-p 5050 vulnerable app. So whatever Docker container I built previously, it is going to run that container as an application on that test machine. So imagine that I have this test machine. I'm just going to run that container on that test machine as an application, as a target application. The next thing I'm going to do is start Zap. And this is an important set of configurations. So I'm starting Zap. This is the Zap sh, which is the bash script. And I'm starting Zap in daemon mode, right? So I'm starting Zap in daemon mode. And I'm exposing it on port 0.0.0.0 and on host 0.0.0.0 and port 8090. The next thing I'm doing is setting up some values for the API, API. So since I'm using Zap's API, I want to be able to access Zap's API, and I've also disabled the API key for Zap. Now, since I'm running it simply in an ephemeral environment, see, the point of GitHub Actions is you don't really have the environment up and running forever and ever. It runs as the job needs it, and once it's done, the environment shuts down. So you don't really need to worry about API keys. I didn't decide to not worry about API keys, but if you want to, you should not include this option, right? So once you're done with this starts Zap, right? This starts Zap in the in that particular test machine. So in our Ubuntu 18 machine, remember, we've started our target app. We've also started Zap. And the next thing I'm going to do is wait for a bit. I'm going to sleep for 20 seconds because sometimes when I immediately start running my test script, sometimes Zap is still not up and running yet. So it needs a little bit of time to start. So I've given it a sleep for 20 seconds. Again, I'm using somebody else's job here. So a lot of people have written their own jobs. I've decided to use somebody else's job, not write my own job. I could do that, but I decided to be lazy and, use somebody else's job. The next thing I did was run my end-to-end script. You remember seeing this particular script, I'm guessing, right? The same script I ran on my desktop, this particular script. I'm going to run the same script, which means it's going to authenticate to my application, all the while proxying the traffic through Zap. And then it's going to start a Zap scan. It's going to run a light Zap scan. So if Zap does not have a light policy, it's going to add a light policy. And it's going to run an active scan. Once it's done, it's going to write a report, and then it is going to shut down Zap. So that's the cool thing. Everything is happening within a single test automation script that we've written. Right? So that's something that's pretty cool with this. So it's running the entire end-to-end test. And once it's done, I've also indicated that this needs to be uploaded as an artifact. So in any CI/CD task, what tends to happen is that you can get artifacts from that. So when I say artifacts, I mean things like results or reports that you need for, to preserve evidence later, maybe. So you want to have that as an artifact. This takes the JSON report that it produces from this script and writes it back to GitHub that I can download and actually analyze later on. Right? So this is triggered whenever I commit code to my master branch. As soon as I commit code to my master branch, this job is triggered. Let's see how this works. Right? So this is the explanation. If anyone has any questions, please type it into the YouTube live feed, and I'll try and answer the questions after I show you the demo. Right? So the next thing I'm going to do is I'm going to make a small change, not a big change. I'm just going to add a line to the readme.markdown file. I'm just going to say this is a Zap test. Now, I'm not making any core changes to the source code. I'm just making some changes to the README and committing it back to my repository. So this is a Zap test is what I'm going to write, and I'm probably going to make this a so I'm going to write that in Markdown. and I'm going to commit this to my repository, right? So made change to readme file, right? And I'm going to commit this. So this is going to push to my master branch. Now, once it's pushed, let's look at what's happening in our master branch actions. So if I go to actions, you'll see that, hey, you pushed some code. I am running this particular job. So let's look at what this job is actually doing. So you'll see that each step of our job is now documented here. So it starts with a setup job. It builds the wait action that we wanted. You remember, I needed to add that 20-second wait on the job. So it builds that as a Docker container. Then it checks out my code, installs all the Python dependencies. It builds my Docker image. Remember, I am building it from scratch. I'm building my application as a Docker container right there and then. So you see that it's being built as a Docker image right there and then. And the Docker image is going to be built pretty soon. Once it's done, it's going to start installing OWASP ZAP. So it's installing all the dependencies in the Docker image, as you can see here. And once this is done, it's going to move on to the next job, which is install ZAP. I think it's almost done. I think we're at the end of that particular install. Yeah, so it's almost installed. All of the dependencies for that application is installed. It's quite a few dependencies. I didn't realize that this horrible application had that many dependencies. But anyway, so yeah, so now you see that it's installing OWASP ZAP. Remember, we are installing OWASP ZAP as a direct service on the operating system and not as a Docker container. So it's installing OWASP ZAP. It's running the container. It's going to sleep for 20 seconds. It's just going to, so it's running ZAP as well. So it's actually run ZAP. It's already running in daemon mode. It's going to sleep for 20 seconds. And once that is done, it is going to run our full-fledged application security test with ZAP against that target application. You remember what we saw on the desktop? The same thing is going to happen, right? So it's running our test automation with ZAP. So you should see the results popping up pretty soon. Hopefully, we should not have a live demo failure. Yeah, you see that it's done. You actually see that the report is actually, the scan is also done and the report has actually been written. In fact, if you see now, you'll actually find that it's written an artifact. And if I download this artifact, you should find our nice little ZAP scan report, right? That's what we wanted. So let's say I want to present this to management or something. You see that I have my ZAP scan report that has been generated from my GitHub Actions. So within a few seconds, we were able to completely operationalize and run a full dynamic application security test with GitHub Actions, right? Now, GitHub Actions, as you can see, is a pretty powerful tool. You can run it with multiple options, with multiple operating system parameters. You can run it parallelly. You can do a lot of that stuff. So it's pretty interesting, right? So just going to paste a few more links for those of you who are interested. Like I said, this is our, I also like this one repository for a lot of very interesting GitHub Actions, which is called Awesome Actions. So you should check it out if you're looking at GitHub Actions. Of course, like I said, we cover this and much more complex and exhaustive examples in our training. So if you want to look at our DevSecOps offerings, you should definitely take a look at this link. We are running remote training since all of you are stuck at home and probably need some very interesting content to engage with. Have a look at our training. We have multiple slots and multiple dates, and you should be able to get a lot of this and more from the training. You get also access to all of our labs, and you get extended access to labs and certifications from all of our training as well. So you can sit and get all of these kind of amazing labs right from the comfort of your own home from those systems. So with that, I come to the end of my broadcast. Is there any questions that I can take? Let me know. You can paste it in the, in your comments or in your, so you can paste that in your YouTube live, the stream that's there. Any questions you have, I'll be happy to take. Or if you want, you can always follow me on Twitter and ask me the question there, or LinkedIn, or what have you, and I'll be happy to do that. The other thing that I forgot to mention was we have a discount code running for our trainings all this month. So if you're interested in our training, you should use our discount code, which is Stay Home 2020. So this is the discount code that you can use to sign up and actually get some very useful discounts for the trainings that we offer. With that, I come to the end. Thank you very much. I hope you found it very useful. If that's the end, if there are no other questions, I'm going to take the questions offline. So I'll see you in our next. So our next broadcast is going to be on next Tuesday, same time. We're going to be talking about a different topic, and we'll let you know the topic beforehand. Please follow us on Twitter and LinkedIn to get details about how you can participate in some of these live broadcasts that we have. Thanks very much. Bye-bye. Stay safe out there.